So first thing is they give a lot of info, they have like dots over there. So they are, for every 9 dots is going to be the next letter, is what they say. Okay, so the reason we choose 9 dots instead of just going every dot is because if there is some inaccuracy in the ticker timer itself or in our measurements, it's going to be minimized by taking bigger intervals. Okay, so instead of tiny intervals. So the total time the entire measurement was done for, okay, for all the dots on a 37.5's little ticker tape was 1.2 seconds. Okay, so then they ask a question that says, okay, what was the frequency of the ticker timer and what is the period between dots? What's the period of the ticker timer? Okay, so frequency, like we said, is like cycles per second, so amount of hammer strike or dots per second. Okay, so in this case, we're going to have to count the amount of dots. So we're going to count the amount of dots on that page and divide by 1.2 seconds is how long it takes. Then we can get our basic frequency. So that's how we're going to get the frequency. Okay? The next thing is our period, is how long it actually takes. So T equals period, F equals frequency. Okay, so our period, how long it actually takes is just 1 over the frequency. So if this was 50 hertz, it would be 1 over 50, 0.02 seconds. So we're going to actually calculate that for the first 2 questions that they ask, where they give the big blocks, and below that, they actually give something where it's like a description where it says number of dots and then period and a time symbol in between. So that's just to measure the time interval between our letters, between every 9 dots. So it's just going to be, if we want to know how long does it take between every 9 dots, it's going to be the period for 1 dot times 9, because now there's 9 dots. So it's just going to be period times 9, and we're going to get an answer of how much time are between my letters A, B, C, D, like this. Okay, so we're going to fill this in and calculate average velocities, and I'll make a separate video on acceleration. But last thing I quickly want to mention, and I'll mention it again in the second video, is when an object moves, it's at the top of page 123 as well. When an object moves at a constant acceleration, the average to velocity, made a mistake here, the average velocity during the time interval. Okay, so average velocity between A and B is going to be the instantaneous velocity halfway between the 2 points. So if it's at a constant velocity, like this one seems to be, it's just going to be the same velocity everywhere. So it's still going to be true that the average velocity over this is the instantaneous in the middle. But even if it was accelerated, so if the dots got progressively further apart, and I said measure the average velocity between points A and B, it will be equal to the instantaneous velocity exactly in the middle. Okay, so that's all the info. We can start working on the activity.